ओके, मैं दिखाई दे रहा हूँ। Okay, another mic. Okay. Hello everyone. I think I'm
ठीक है।
visible. Okay, we start the recording. Okay. Okay. So, okay. Any of you guys is trying to make bot from this course or something right now? No. Okay. So my today's plan is, I will
मैं बना रहा
summarize.
हूँ ब्रो।
क्या बना रहे हो? Drone bot.
बॉट बना रहा हूँ दोनों कोर्सेज को यूज करके, जो सीवी वाला कोर्स है और ये वाला कोर्स।
Okay. So
सो
what I am planning today, okay, I will just give you complete summary of the entire course. Okay. So okay, I think let's start. I will explain in the middle of it. Okay. So first, I think I have explained about the rover rumble bot, right?
हाँ, वो
Yes.
लास्ट लास्ट सीजन में कर लिया था।
Okay. So my today's goal is to explain the simple bot actually. Okay. Using, I think I have suggested you guys ESP32, I guess.
You told about ESP32 and ESP8266.
Yeah. So okay, let's understand how this works mostly. Okay. How many of you here like know about a microcontroller first of all? Yeah, you can speak up. My screen is visible, right?
हाँ, म्यूजिक वाला।
Okay. So first of all, just let me know what is a microcontroller. Any idea, whatever you have, like, you can just speak. गलत जी बोल दो भाई कोई
सिस्टम
दिक्कत
ऑन
नहीं
चिप।
No, that is
सिस्टम ऑन
SOC.
चिप
That is
जिसपे
SOC. SOC is different. That is like your RPI and all is this thing. So
वो
SOC
तो
is something.
प्रोसेसर हो जाएगा
It's
ना।
like a complete PC on a single chip. That's called system on chip or SBC, single board computer, whatever. Okay, that's different. So what is a microcontroller is?
माइक्रो कंट्रोलर लाइक
A
एक्सटर्नल
microcontroller,
हार्डवेयर
we have
जोड़ते हैं।
a small processor,
Hmm.
SRAM, and also the storage. We have
Uh,
some of the ADC and DACs,
hmm. So
and
what is
we
the
have
like the basic
the
functionality of a microcontroller?
communication.
I'm just asking. Basic functionality. I'm not going in too deep of like how it works and transistor level things. What it does mostly.
we can we can program it for
It
various
stores the
projects.
program and then it runs according to it.
Yeah, correct. So actually, the basic purpose is to control something, right? It's a controller,
Yeah, yeah.
right? So we program the microcontroller to do certain tasks to control some stuffs like taking data from sensors, executing in some actuators or something like that, right? So that's the basic purpose of this thing. So uh, for this project, like bot building, also we will use that. Okay, that like this will be the brain of our complete system for now. Okay, okay. After brain, what we need the actuators, like the things which
हार्डवेयर
will be controlled.
हार्डवेयर
Huh? Hardware, right?
हार्डवेयर
Yeah. So in hardware, what we have actually the complete thing is hardware, but still I will just consider hardware as motors or something. Okay,
मोटर्स
Motors again.
एलईडीज
LEDs or blah blah stuff,
And motor drivers.
डिस्प्लेज।
displays. Okay. So for now, we will just
Motor
implement
drivers.
motors. Yeah. No, wait. I will just explain what motor driver is exactly. So microcontroller will control motors because we are using like we are making a rover. Okay. So I have one rover here. So I will explain this as well. So what we are doing is using microcontrollers, we are controlling motors, right? At the end, correct? For now, like for this quiz, we are using this. So I will tell you something about this. Any microcontroller you will take, okay, it has some limitations, right? Limitations of what? If I want to drive a motor,
Like
will I able to drive a motor using a simple microcontroller? Is it possible? What do you think?
Battery.
I
Like,
think there
see,
is some voltage limitations.
not a voltage limitation. There will be a current limitation actually. Okay, I will just show you.
Milliamps.
Yeah. So how
Yeah,
what
some microcontroller GPIOs can only deliver up to 50 milliamps,
Mm.
like
exactly?
or
So I
500
will just go
milliamps.
for ESP32 pin only. Okay, GPIO pin can provide. Okay, it's 40 milliamps, right? And for a simple BO motors, current required for BO motors. How much it is?
180.
180. So will it be able to drive a motor? Is it possible?
No.
Actually,
No,
it is. Actually, it is because when we just provide small amps to a motor, it will work. It's not like it will not work. It just like as you
like
can see
it
here
will
as well.
work, but not
Yeah.
in that height.
First of all, this is not safe. Okay. As you can see, it's like between 40 to 180, right? So it's 40. So it can somehow just start the motor, but it's not sufficient to make it work properly, right? So
For long-term usage.
yeah, for long-term uses also it is an issue because your microcontroller will get heat up a lot, right? So for that reason, we need something which can drive current, okay, to a motor with signal from a microcontroller. Okay, so a black box is required, which will do this task. Like microcontroller will give the command, and the maximum current whatever motor needs, it will just apply to it. Okay, so what we'll use for this case? What do you think? What will implement here?
Step-up booster.
Mm, Technically, we can use step booster.
Maybe a transistor or a MOSFET.
Yeah, so we'll use a MOS. Okay, I'm not sure how many data science students are here. So, okay, how many of you don't know about MOSFET? Just raise your hand. Okay, I'll just explain you in brief. Okay, so a MOSFET is something we have three wire from a MOSFET. It is like in okay, okay. So when I will give signal to one pin, like the gate, it will just make a connection. Okay. And when the signal is zero, okay, then it will break the connection. So it is like a switch. When you will give a small voltage, it will just like make complete circuit. And when we'll just make it like make the signal zero, it will just break the circuit. That's it. Okay. Did you understand what I told? I don't know. Okay.
Yes, yes.
Sure. Or I can like explain again.
In simple terms, we can also say na that it's a electronic switch.
It's an electronic switch. When we'll just give you voltage, it will turn on. When its voltage is zero, turn off. Simple. Correct?
Yeah, yeah.
Okay. Okay. So we'll use a MOSFET, but in a clever way. Okay. Because we want to like in a motor. Okay, so motor driver is just bunch of MOSFET. Exactly what I want to say. Okay. So we'll go for this now, which is a H bridge motor driver. I think you know this one, L298, right? Motor driver, this one. You know, right? This one.
Hmm.
So what is this exactly?
Okay.
What is this exactly? It's a bunch of MOSFETs only. Okay. So I will show this one first. Yeah. See. MOSFET or transistor, whatever you say. Correct? But why the arrangement is like this? Like here we can just make a simple this one, right? Like this also. But they have like something complicated with four MOSFET or something. Why? If someone can understand
Um,
this.
the motor will move both anti-clockwise and clockwise as well.
Exactly. So for that reason only, we have like make a circuit of four NPN transistors so that we can like reverse the directionality of the motors in both the side, right? For example, in this case, we have shorted S1 and S4, right? So it's just current going through this path, right? Correct?
Yes, correct.
Yes, yes.
Just copy this. So in this case, current is flowing in this direction. So the motor will rotate in this. I'm assuming, I'm also not sure for this one, but still I'm assuming in clockwise direction, right? So if you have somehow tried, like if you just change the terminal of the motor, like plus to minus and minus to plus in a motor, it will just reverse the directionality of the motor, right? Correct?
Yes, yes.
So the same case will be here. When I will just like make this close and this close and make it open, this one also open. What will happen? The current will flow through this now. Now the motor will rotate in this manner, right? Correct? Yeah. So this is how we'll control this bot going forward and backward, right? Correct? Now motors can rotate in clockwise. Maybe I will just assume in forward and anti-clockwise for backward motion, right? If we have four such this combination, then I can control four motors of this bot, right? So this is done. Now, if I want to control the speed of the bot, what I can do?
We can adjust the voltage
Adjust the voltage. Okay, nice.
or use
Anything
a
you can
speed
think of?
controller, something
Hmm.
like speed controller we have.
Speed controller. I still didn't get it, but okay.
We can adjust the gain of the MOSFETs.
Hmm. That will be like a different case. It's just like complicating the things. I want to, it's like simple thing. Changing the voltage will like help in controlling the speed. That's right. But interesting fact I will tell, just like any microcontroller you will take, okay, it cannot create an analog signal. Okay. So what we'll do in this case?
We'll simply generate a ppm or a pwm signal, that is a square wave signal.
Exactly. So we need PWM for this case now. Okay. What is PWM? It's this. Okay. So for example, I have a signal. Okay. Is it too getting too complicated? I'm not sure. Maybe for some people it's getting. Okay, if it's getting complicated, just ignore these things. Later we will come to simpler things as well. Okay, no issues. Okay, so if I have a voltage which is high for all time, so it's like 100% efficiency, like 100% time it's on, right? So for example, I have a motor connected to a source which is all time on, then it will be like 100% speed, correct? And if I have a motor turned on and turned off after some time, and then again turn on. For example, this is 75% time it's turned on. So the if I am doing this very fast, okay, like this pulse I'm creating very fast, then you can't even see it's turning off and on. You will see the motor is getting slow, right? And the speed will be 75% of the actual speed, right? So in this manner, we can create a PWM signal. This signal is called PWM signal mostly. Okay. And then in this manner only we can control the speed, like this is 75%, and this we can go for 10% or something like that. Right? So this is how we can control the speed of a motor as well using this simple this one only motor driver. Okay. I hope this much you understand. Uh, As we increase the duty cycle of the signal, the speed increase and vice versa. Yeah. Okay. Okay. So we are using a square waveform. You can use this for triangular waveform and all. So that's a different case, but still we'll just stick on this only for now. Okay. So now what we have a microcontroller which is connected to a motor driver, which is controlling the motors. What else we need for a bot proper? Any idea? Like at least this turning
The
on and all.
code.
Exactly. So now we'll write the program to make this thing work, right? According to our need. Okay. I will just show you a simple code. Okay. I think I have shared the same code previously also. I will just try to explain a bit. Okay. So now let's come to this thing. How this bot is moving actually. I hope this is visible to you guys. Is it visible properly to you?
Yes, it is visible.
Okay, for you guys. Okay, now it's better. Okay. So for example, I have to define four motion for a bot, right? First is forward, second is backward, third is left, and fourth is right. Simple, four motion. How we can do this in this simple bot? Because we don't have any steering to just control like the angle of the front wheel or something. How we can do that without that? Like we have power in four wheels, so somehow we have to manage with that. Any idea?
For backward and forward, we can simply rotate all the wheel at one direction. So it will go simply
Yeah.
backward and
So
forward.
for forward, I
And
will just go for this, like in the same direction.
uh,
And for
yeah,
backward, reverse the directionality using our motor driver, X-bridge driver, right? Yeah.
and
And
for left and right, we can simply so for left and right, we'll use a coupling effect. So we'll rotate the right motors in one direction and the left motors in opposite direction. So it will rotate in left or right
correct.
according to the like direction of the motors.
So, for example, I want to take a right turn. Okay, for this turn, I will just make this thing clockwise. Is it clockwise? No, sorry, anti-clockwise. Okay, anti-clockwise. This will be clockwise. Okay, so it will take a drift like this, right? It's going forward. This is going backward. Then this will create a turning effect. I can show in the whiteboard as well. For example, I have a bot to create a torque. Uh, should I call it a torque? I'm not sure for this. See, torque is responsible for the motion of the bot because if torque is not there, we can't even move the bot, right? But I'm not sure, is it like completely due to torque or something? Maybe, yeah. Okay, for now, this is the bot we have. If we'll just move this motion, this is forward, right? And the same thing if I will do, for example, okay, for backward motion, what I will do, I'll just simply change the directionality of the motors to this. This is backward motion. Okay. For a turn like this and this, what we can do is simply I will just change the directionality of this motor. Okay, like this and this. Getting what I'm doing here? This will create an effect like this, right? So this is the complete motion we have. Now we have to write the code for this. Okay, so let's see side by side only. Okay, for example, right now we are using Wi-Fi based board because we have ESP32 or maybe ESP8266, whatever. We need like we have a communication of Wi-Fi and Bluetooth, but for now I will use Wi-Fi only. If you are going for a Arduino based board, we can use a HC05 module, which is a Bluetooth module you can use and directly control the board using Bluetooth, right? But for simplicity, I have a Wi-Fi here. I will use that only. Okay. So first of all, in code, we will include Wi-Fi. Okay. And okay, I think so. I should explain this one as well. In ESP32, okay, we have multiple options of controlling things. Okay, we can create a web server. Uh, okay, so for example, our ESP32 is working as a web server in which our website is hosted, and using some other network like other device, we are going to this server and like giving command to this ESP32, like what we want to do, like that. So we are using that like here. Other options we have is like you can make ESP32 as a sole router. Okay, like it will be acting as a router. Like okay, sorry, my bad. Okay, this is what we are doing as part of this the code. Okay, but in ESP32 we have multiple options. For example, right now I am using Wi-Fi in which a router is connected to a ESP32 and a device like phone. Okay, and phone is like giving access. Like sorry, ESP32 is giving access to the phone to access the website. Okay, what is that? Wi-Fi extender. Can I use it for a Wi-Fi extender? See, you can use ESP32 as Wi-Fi extender or something, but ESP32 is like very low power device, which will not work for you. Like very see, like these routers are very high power. Like I think this takes 12 volt or something and very high amps. So this is not possible to just act like a proper router. But still, you can do it. I will not say that you can't do it. So yeah, first case is a router is connected in between your phone and ESP32, which is helping in communication. Okay, between phone and ESP32. The second method is you can use ESP32 as a router and connect to your phone directly. Here, no router is required, and you can just directly access to ESP32. Okay, and yeah, these two methods mostly we use, but yeah, this is the most easier and a preferred way just because your ESP32 is not that powerful. So it's very inefficient way to just do this thing. But yeah, when we are using in like very isolated location, for example, I am in home, I can use my Wi-Fi router. So I can just directly connect my ESP32 to my router and just make it work. Okay. But if you are in an outdoor condition, we have to use this connection or communication. Okay. So yeah, ESP32 is hosting a website. Website is getting access by our phone or our PC. Done. Now what we are doing? Okay. So okay. Now for getting access of your router, I need the SSID. SSID is like user ID of your router and password of your router, so that I can like get connected to the network, right? And 80 okay, so after connecting to your network you need a this one port, okay, in which you will give command and receive commands. Okay, For here, we are using 80. Mostly we use 80 only for some sake, I don't know. Now, we have motor pins. If you have program any microcontroller, we have defining your pins. For example, this is a variable X for your GPIO pin 27. Okay. This is motor pin 1, pin 2, GPIO pin 26. So in hardware, I can show here. Okay. So here you can see in this we have this output. This is connected to our motors. These for its two motor we have this. After that, what we have is enable A and enable B. Okay, and these four pins. Okay, if you want to like implement PWM, you have to use these pins enable A and enable B. If you don't want to use it, just ignore that. Okay, and IN4 to IN1, these are the pin responsible for the motion of your motors. Okay, I will explain that later a bit. These are the power line we have to connect. Okay, now I'll just explain you a bit of circuit as well. So this is my ESP32 and this is my motor driver. Okay, I have four pins for now. Maybe I will to enable A and enable B as well for now. Okay, and I have connected to four pins of this two, three, and four. Okay, now these pins, for example, I have denoted here with some numbers. So, okay, for example, motor pin 1 is connected to 27. So I will name it 27, 26, and here 33 and 25. Okay, 33 and 25. Okay, and here you can see enable pin and enable pin for B, like second motor. So I told the duty cycle and PWM. So where we'll send that PWM signal is actually in this pins. Okay, in this is like connected to 32 and yeah, it is connected to pin number 40. Okay, so ESP32, these pins are there. I will show pin out of ESP32 as well for better clarity. Okay, so as you can see here, GPI pin 36, 39, these are the GPI pins. This is what I have mentioned here. Okay, for example, your enable pin is connected to 32, which is here, right? So we have to connect one enable pin here and second enable pin in 14, which is here. Okay, and you can see this tilde mark, right? So this is for PWM enable pin. So you can see most of the pins are PWM enabled here only, right? So you can use most of the pin for PWM signals. No issues with that. But in case of Arduino and all, we have some limited pin for PWM. So you have to consider that as well. Okay. Okay. So now we have assigned these pins. For example, 27 is connected to one of the motors, 26, 33, and 25. As we'll connect this motor driver to ESP32 like this. Now, what's there in the code? These pins are assigned now. Now we'll go for some PWM frequency. Like I told, there is a speed, right? How much we can push this ESP to for a PWM signal. Okay. So right now we are assigning here how much? 30 kilohertz, which is very high speed, right? And resolution is 8 bit. Like a value of this PWM signal will be 0 to 255, which is moderate in ESP32 in your I think sorry Arduino it will be less. Okay, and as I have told, duty cycle initially it's just assigned to 0, and then we'll change in the code for more speed. Okay, string value 0 for sliding value from web page. So this is part of web pages. Okay, and now here we have a web page. As you can see, it's a HTML code, right? So this HTML code is responsible for like posting a website in the ESP32, because we are putting a code of a website in the ESP32. It is generating and getting signals like this. For example, we have created a function: move forward, move left, move stop robot, move right, or reverse, like this. So when we'll click on that buttons, it will just send these commands. Okay, and we have to like make these functions as well, like how it will move when we just get the function of like forward. For example, forward, what it will do, that function will create later, right here. Yeah, Sudhanshu.
Uh, what if we will not add our web page in this the code of ESP32?
Hmm.
I mean, it is mandatory to add the web page.
No, actually, what I was trying to tell is, in ESP32 we have multiple communication like things, right? We can use Bluetooth also. So when you will use Bluetooth, we don't need a web server, right? But we are using a Wi-Fi here. So Wi-Fi, we can utilize a web, like make a website which I will host on my ESP only, and then I will just take access and just control the bot. Simple. Okay. Somehow I have to just give the signal to my ESP. If you remember, we have did something in our rover rumble. So in there, what we are using, it's a very different technique. It is called MQTT. It's a different communication, but still it was using Wi-Fi to get the data, right? For example, I'm like, you guys were sending data to some network, and that network was like collecting data for MQTT, and MQTT was connected to the bot, like the ESP, and the ESP is receiving the data from that like command you have sent to the MQTT. I should explain like this. So, for example, we have a bot here. Bot is locally connected to a router, okay, Wi-Fi. And this router is connected to a global network, which is internet. Okay. And this internet is getting data from MQTT, like a MQTT broker. Okay. In this internet, we have MQTT broker, which is like a server. For example, we have used a EU server. Okay. EU, Amazon, AWS. So it was going to EU and getting data. For example, you are sending like your device user is connected to this server, and you are sending data from your side to that server, and this server is sending the data to your local router, and the router is sending that MQTT command to the bot. Are you getting what I'm saying?
Yeah, got it. Thanks.
Yeah. So this we are using in case of like a global network. But right now we have a local network, so we are just eliminating these things. We don't need these things actually now, as these things are part of internet. Now what we have is a simple bot which is connected to a Wi-Fi, and in case of internet, we don't need internet now. We can just connect your phone directly, and this will communicate to a bot in this way. If you have Bluetooth, how it will work? In the same way, bot is like having Bluetooth. It's directly connected to your phone, because your phone have access to Bluetooth. In case of Wi-Fi, also I told before, you can directly connect to your phone as well. It will act as a host. Okay. Apart from this, we have Zigbee and other communication like networks also. We can use that as well. So that's a different case. But for general use case, we use Wi-Fi and Bluetooth only. And I will prefer go for Wi-Fi first because it's very easy to use, and then shift towards Bluetooth for some use cases. Okay. Okay. Now, okay. These are commands we are telling, right? Zigbee बहुत महंगा आता है शायद. That's for now. Just don't consider that. Cost is a different thing. For now, I'm just telling like these are the communication you can use in some manner. We can use this one LoRa also. For okay, if you are using like working with drones, you have used LoRa somehow. This is for long range. You can't use Wi-Fi or Bluetooth there because Wi-Fi and Bluetooth have a very short range. You have to use LoRa because you need a long range because your drone is going a bit far than your Wi-Fi range, right? So these are different communication we have to use. Yeah, Priyanshu.
In drones, we specifically use the long-range modules of the NRF24 because LoRa have a much lower bit rate, so that's why we
See,
have latency issues.
at the end, whatever you use, it's a part of LoRa only. So the depth, see, LoRa is like somehow it's just a name. Say, for example, it's like a long range. It's not a proper communication protocol. It just like you guys are using NRF. Okay, NRF is built on LoRa. Okay, they have like enhanced the functionality of LoRa to just make it a long range. This one communication protocol. Okay, for example, you seen like BLE, right? Bluetooth Low Energy devices, something like that. BLE devices. So that is part of Bluetooth only, but it is somehow like made in that way, so it will consume less power or something. But it's part of Bluetooth only, right? So in that sense, I'm telling. Okay, so yeah, I was showing this one. So as we have mentioned, how it will work. This one. Okay, I will explain a bit. Okay, so yeah, now I will explain a bit of motor driver again. In this, we have four pins, right? So the designer of these motor drivers, they have simplified this thing a lot so that now if I want to, like I have told, you can just reverse the this one connections and make it work like this. Like we have to change the connections to make it work in a proper way for forward and backward. But the designers of this motor drivers just make this thing simple, right? For example, if I want to move this motor forward, I have to just give high signal to this pin, then it will go forward. Okay, if I will high this signal, it will go backward. If I will high this pin, it will go this way, and if I will high this pin, it will go in a backward. Okay, so these four pins will help us to identify how your motor will move. Okay, so now as you can see here, your motor 1 pin 1 is low and motor 1 pin 2 is high. Okay, so it's just stopping the backward motion and just enhance like going for the forward motion. Same for motor pin 2 as well. We have four pins, so two pins we are making high so that it will go in a forward direction. Okay, and for this one right also, sorry, not right, for reverse, see just the opposite, right? So it was like first is low, high, low, high. It's like high, low, high, low. So it's just like the reverse case. Okay. For left, as you can see, low, 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 and this is only high. So it just so this is one way. Okay, I will also tell this. So this is just stopping these motors and just moving these motors to just make it move like this. Oh, sorry, like this. And when I will just move these motors, this will go like this, and you are stopping these motors. But I was telling you will just like this will create a bigger arc, but if I want to create a smaller arc, I will just implement a high here, so that wait, not here, here. Okay, if I'll just make a high, so it will just create a smaller arc. That's it. Same case here as well. Here only this one is high, so I will just implement a high here as well, so it will just make a smaller arc. That's it. I hope it's clear. And for stop case, we have all low. Are you clear with this thing? Or I can explain it again. If you guys have any doubt, just let me know. Okay, so yeah, for speed control, here as you can see, you have if speed zero, stop the motors. So like whatever we have discussed in the this one duty cycle section, here it just mapped to 25 2500 200 and 255 as it was a range of 25 to 100 and PWM cycle of 200 to 255. Okay, so it's just like a slider we will get in which we have 25 to 100 which is mapped to 200 to 255. Okay, and enabling pins. So these enable pins are used for controlling the speed, as I have told. So you will just send the PWM signal to these enable pins, and that will help us control the speed of the bot. Okay. Now the actual setup is here, which is helping us in controlling the motors. So when you are starting the bot, all motors should be like in an output mode. Okay. So when we are using a microcontroller, we have to define, okay, like this pin is for input or output. For example, we have used motor pin, all the pins are in output mode. So whatever thing we will just give, it just help us the like output of the thing, right? Sorry. Okay. So for example, I have motor, sorry, microcontroller, which is having some GPIO pin. So GPIO pin stands for general purpose input output. So it can work as an input or output pin. Okay. So if we want to use it for just getting data, we have to make it for output. Or if you want to receive some data from output from some source, we'll just use input. So for right now, we are just like giving the data to motor driver. So all pins are in output. Okay. I hope this is clear. And yeah, okay. So for PWM, we have this enable pin frequency and resolution. We have assigned to these things. And okay, with start speed 0. Okay. So when everything is starting, so it's assigned to 0, and frequency and resolution it's taking from here. Okay, in this part. And okay, after that, this is the actual code, like how it will start. When we will just power the like microcontroller, it will show connecting to that network. So in this process, it's trying to connect to the network we have assigned. So I have given the SSID and password here. So it will let the Wi-Fi of this mod, like the microcontroller, will try to find this network, this SSID, and use that password. If it will found that ID, it will just put that password and see if it's working or not. If it's not working, it just show connecting and dot 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 like that. Okay, but if it's like connected to this ID and password, then it will just show the IP of that thing. Yeah, here you can see it's like connecting dot dot, and if you'll just get the IP, and so after taking that IP, we can put in any connected device to the router and make it work. Like you will get the website which is here. Okay, this website will get in our that device, whatever like in which we have opened that IP. Okay, so yeah, and then we will just get the functions like here, as you can see, we have defined this function left, right, forward, these things. So we will receive that in our ESP, and these will assign to these functions. Okay, handle right, handle stop, whatever function you were sending from your phone or any device connected to that network. Okay, I hope this is clear. Website page in the code. Actually, I can. And just like I have is ESP8266 right now. I will ask ChatGPT once to just make this code for ESP8266. I'm not connecting anything right now. I will just show you guys. I will just convert this code for ESP8266. Okay, so there are some functions and all, which is not functions, sorry, libraries, which is different for all the modules. Okay, for example, if I'm using a servo in Arduino, the same library will not work. For example, you can see here, Wi-Fi library in ESP32 is not same as ESP8266. ESP8266 have different Wi-Fi like library. Okay, web server also it have a separate ESP8266 web server. So these kind of things we have to change for that reason. Okay. Yeah. If anyone have any doubt, you can ask.
Like which connection will be stable for both Bluetooth or Wi-Fi?
What is your use case? That's also a point. If it's like a very simple,
Like there is an
okay, just one
like
second.
TCS Ion nearest to me, and
Okay, like you have your PC nearby and you just want to control that.
yeah,
Okay, so for that reason, you can use
mm,
Wi-Fi, easiest one. And if you have like a very remote device, like you have a like phone, and you are going for some competition or something where you can't use Wi-Fi just because you don't have a router or you can't rely on that web server, then you can use Bluetooth as well in that case. Okay, I will like download this because I don't have installed yet in this PC. Okay, I will explain this as well. Arduino ID download. Okay, simply you go to this website and okay, for ESP8266 in Arduino. Okay. Okay, if you guys have any doubt in code or any hardware, just let ask me. Till when I am just installing this thing. Okay, apart from this, okay, somebody have asked me about SBC, right? Single board computers. So, uh, you can use a SBC also if you guys know about Turtlebot or something. Do you guys know Turtlebot? Or have you guys seen these things, these bots? Anyone?
Yeah, yeah.
You have seen, right? So, this is a very interesting thing. Okay. For now, what we did is it's just like a simple bot having wheels which can move around and do some tasks. But if I want something autonomous, okay, for example, if you have seen some vacuum cleaners, right? So they don't need any program, like no, any a person to just control that and just move around the room. So, for example, Roomba is there, right? So these cleaners, like these are the very smart cleaners. So they also use this only. Like they have simple mechanism of moving around the room. So how they do it? Any idea? Do you guys have any idea how they do it? Hello.
Yeah, so firstly they map the whole home. So they get some coordinates in the matrix, and then they have some couple of obstacle detection sensors, like some with lidar sensors and some ultrasonic sensors, also some like if it stumble upon anything, so it get that switch kind of a sensor, so it just rotates and see where there's no obstacle and just goes on to it.
Actually, it's not that complicated.
they,
It's very simple. Okay, I will not go in that deep. See, you know, lidar or ultrasonic sensor, right? It can measure distances. So what it do is it's just like a simple bot is there. Okay, for example, okay, for example, this is your Turtlebot or Roomba, whatever. Okay, this have a sensor here, simple. This is a room, and we have dropped this thing somewhere in the room. So it can detect like okay, something is like in this shape, okay, and nearby nothing is there. So it can move till this much, okay. So these processing are done in SBC because these microcontroller is not that capable to do these kind of things. For that reason, they have SBC which get this data. Okay, I will show. See, this kind of mapping it do. Okay, for example, it came this closer and just saw there is something in this side, so it will just clear off this side and just clean this much only. Okay, getting what I'm saying? It have a lidar which is detecting all the obstacles nearby and it's just moving in the empty space. That's it. So you don't need to map anything. But yeah, you can utilize this thing and get a map of your room. For example, after all like movement of your bot, wherever it's going, you can just see, okay, this is my complete room from a top angle view. Getting what I'm saying?
Yeah, yeah.
Yeah. Okay, now as I have opened installing this thing, so I will explain this a bit also. So after, okay, I hope this much you can install. When we are using any ESP8266 or 32, we have to just install it manually. Go to Preferences, place your link here, then OK. Okay, now we have to go to ESP. Now you can see ESP8266 install. So it will take some time and it will install the necessary drivers for your board. Sorry, the board. Okay, don't disturb this thing because if you'll disturb, it will just the file will be corrupted and you can't even use that thing. Then we have to reinstall everything. Okay, so yeah, I was explaining this part. So for using like for making these kind of things, we use ROS mostly. Okay, ROS stands for Robot Operating Systems. Okay, so uh, whatever things we are making, actually ROS is nothing. It's just like an operating system which help us to do all these things like this mapping and all in a very simpler way because they have pre-made like systems and all which like it's developed by some programmers and even from industry as well. Okay, so they have mapped these things, programmed these things. So it's just like a framework you can use to map things and make it work. It's just like simplifying the things for you. That's it. Okay. So if you get interested in making bots and all, then you can just explore these fields as well. And these are relevant to industry, so you can get job in these fields as well. Okay. So this is installed now. Okay. So if I'm connecting, it's just showing board 7. So this is my board. As you can see, it's showing USB here. And now I will just go for ESP8266. So many people are getting error here as well. In that case, if you're getting any error, you have to install a driver specifically for this thing. I will just explain that as well. For now, it's just like a generic ESP8266 module. I will just click on that and just OK. And yeah, I will just copy that code here and just like paste. Okay, now I have to map like my ID. Okay. Okay, now I'll just upload the thing. It will take some time to upload. Let's see how much time it takes. So right now, just compiling the code. Okay, I was telling if you'll get some errors. So sometime it will happen like when you are connecting your board, it will not show here. Okay, okay, I have this error. So in ESP 8266, there is some issue. I don't know why they have this, but yeah, you can't use D pins directly. You have to just mention GPIO pins. Simple. I'll just put random. I hope it works. Okay, I was telling. Yeah. So as you can see here, I'm not getting any error. Okay. If you're getting any error, you have to install the CH340 driver. I will show that as well. Okay. If you're not able to see your device coming here when you're connecting your USB, you have to install this driver, which is here. It will look like a shady website, but yeah, download the here just to have installed this thing, and then you can install from here, or you can just go here and update driver, something like that, and you can just upload the thing directly. That okay, this is one thing. And I am getting some error here. Let me just ask to resolve this one. Okay, till then, if you can like try to install your like if you have not installed any Arduino ID, you can install and just try it once if you're getting that issue or something. Yes. See, for now I'm just using. I also don't write all the codes. I have like plenty of things used by ChatGPT only. Don't worry. Yeah, but I will suggest you guys to try to write your codes. I will not encourage you. Okay. Yeah. Okay. Till then, I will show my bit. Let's see. Yeah. So I was planning if I will just complete this course, we will go for this one. This is one of my biggest project I have made. Okay. This is LLM based assistant will which help us like automating all the things. For example, we have IoT, we have your PC command. We don't do anything. We'll just ask the PC to do that, and it will execute that thing. And if I will get time, then I will implement this one as well. Terminal assistant. So we don't need to write any command for Linux. It will be like you just ask, like I want to do this. It will just do it by its own. Okay, you don't have to program anything. It will just try to get that things and execute it for you, like that. So these two things I have. Maybe if I'll get time, I will try to explain that as well. Then let's see how it goes. Yeah. Okay, till here, if you guys want to ask anything, you can just ask me regarding hardware or programming.
I had a doubt regarding hosting the web page.
Hosting the web page means like okay.
Service.
I'm not getting what you're asking exactly.
So,
Just could you please elaborate like what you're asking first?
like, how do we exactly host? Like, how do we exactly host a web page through a microcontroller like ESP32 or
Okay.
8266?
Okay. Do you know how a
That part.
simple this thing works? Okay, first I will just show this thing. Yeah, it's done. Step with this thing. Okay. So as you can see, we are getting a worst of timer issue because I have to like choose some pin which is somehow hindering this ESP to boot. Okay. So for that reason, I have to just see like which pin I can use. So yeah. Yeah. Okay. Let me try to explain that thing here. Okay. So in normal case, we have what? Okay. What do you mean by cloud? First of all, I will just ask that. Then we can explain it further. Do you have any idea about cloud? How it works? Like mostly, what is cloud actually? Hello, the answer, right?
Yeah, yeah.
Yeah. So what
Can
do
you
you think? How
repeat?
it
Like,
works? What do you mean by cloud? Like how it works mostly?
what do we mean by?
Cloud. Like the actual connection between the internet to your PC, something like that. I will ask. Yeah, but
Like the cloud is basically like a server,
hmm,
like a computer running with a huge processing power and a huge storage space,
hmm,
and which is connected via internet.
hmm, exactly. So assume your ESP32 as a uh, like cloud, for example, or what server. Okay, it's a very low powered server, I can say. So for now, what's happening is ESP32 have storage, right? Or maybe whatever microcontroller. I will just assume 32. It has some storage. In that storage, we have stored a website. Okay. So how it happened in a normal server is the website is open there and you just access using your device, right? Am I correct?
Yeah,
So the same thing happen
yeah,
is
yeah,
your website, which is your HTML code. Okay, this HTML code is saved in your ESP32, correct? And this HTML code you are
yeah.
accessing using your device. Simple. Are you getting? And this code
Okay.
only what we have saved here. Okay, this is the code which in ESP it's just stored, and we are accessing using the network we have in the like the network we have. Okay, yeah. So
Okay.
we have a Wi-Fi communication between our phone and ESP, and the data from here to here is just getting, and we are able to see a website. Okay, so now I will show the website as well. Okay. Hmm, yeah. So I will just restart. Okay, now just start connecting. Okay, now I got the IP as well. Okay, now yeah, here's the IP. Okay, I will just open this thing side by side. Okay, now if I will just send a command of forward, see, HTTP server started and it received the command forward, right? Whenever it will just push the command stop, it will just send command stop. I can show this thing as well here, I guess. Okay, sending info. Okay, anyways. So this is sending command to ESP, and ESP is receiving command and executing according to our need, which we have mentioned in the code. Okay, and this is motor speed we are setting. Okay, it's just like 25, 20, 50, 75, 50, 7500 like that. Okay, I hope it's clear. Done. Okay, now if you guys have any doubt,
Yeah.
and we can just now wind up. I guess it's a very long session. I guess 1 hour, some minutes, 13 minutes. Okay, if you guys have any doubt, just let me know, please. Or yeah. And if you guys are trying this thing, just try it. Whatever issue you will face, just try to put in group. Me and someone, or like Okami or Arunya, they will try to help you guys in that. Okay. I have mentioned this error. This is a very common error because last time some student tried and they got this error, CH 340 driver error. So after downloading and installing, this error have like resolved in most of the cases. So yeah, that's why I have mentioned in the first place only. Apart from this, mostly it will run smooth, and this is a one-time process. Okay, after installing this thing once, you don't have to worry. You just connect and upload. Done. Nothing else. Okay. And still, if you get any issues, just let me know. We'll try to help you out. Okay. I hope it's clear. So yeah. Uh, Ananya, yeah, please. Your audio is not clear. It's very low. Okay. Yeah. So I think it's done. If you want to ask something, you can just type in chat as well. Where is this code? Okay, I have used the code from some place. I also don't know. Okay, I will mention it here. Okay, random tutorial. There is a website. You can just refer them as well. They have a code for ESP32. Okay, this code. Yeah. Anything else, guys? Okay, I just want to know like how much you understand. I'm sure like you didn't get 100%, but yeah, still.
Almost 90 to 95%.
Okay, nice.
80 to 90.
Okay. What about others? Same for what? 80, 90 or 70, 60, something like that. 80, 90. Okay, that's good. I think that MOSFET thing is not clear to you. I'm just hoping so. Which thing is not clear to you guys? Maybe I will just upload a simple video for that specifically.
I had one doubt regarding that web page thing.
Yeah.
So after we like turn on the ESP,
Hmm.
so we need to connect our device with the ESP, right? Or just directly go in the browser and
Okay.
paste the
I
yeah.
will show. Wait, wait. What you asked? I forgot. You were
Like
asking.
for the
Hmm.
connection between the device and the ESP, should we directly just go to the browser and paste the IP address, or we need to connect it beforehand also
Wait.
through the Wi-Fi?
I think you got this. Sure. Just give me one second.
That is the only doubt I had. So,
Just give me one second. Try to resolve that maybe. But I think the answer. Okay. So yeah, it's visible, right?
yes, yes.
Yes.
Okay. So this is your Wi-Fi mostly. I'm hoping like you are using a Wi-Fi router, okay, which is provided by your broadband service provider or something like that. Okay. This have some SSID, which is the ID, like the ID in which you click and just put your password and done. Okay, that is called SSID and password. Okay, so your phone or maybe your laptop or something, your PC also. Maybe right now I'm using a wired connection. As you can see here, I have connected my PC using a wired connection. Okay, but in my phone, it's like directly connected to Wi-Fi. Yeah, it's connected to my Wi-Fi, right? So
Yeah.
uh, my PC or my phone, they are also connected somehow using my router, right?
Yes.
Phone and my PC. Okay. These are also connected via this router. Like if I'm sending a data to my PC, I can use this communication and just send it to my PC, right? And same vice versa also. If I want to receive something to my phone, I can use this same network and the PC will send the data to my phone. Done. Same case here. Okay. If I am putting my SSID and password to a ESP, okay, ESP32, this will also connect to this network. This is also part of this network now. So if I want to control this thing or send data, receive data, I can use this network only. So I can use my PC or my phone, which is connected to my Wi-Fi. Are you getting what I'm saying?
Yes.
Is it clear?
Yes. Yes.
Okay, so if I'm explaining this, so this is the backbone of IoT, okay, Internet of Things. So if you have any smart light or something, this is also operate in the same way. Okay. For example, if you have seen Alexa, right, or any smart assistant, so Alexa is also connected to your Wi-Fi. Okay. Okay. My Alexa got turned on. Sorry. Okay. So Alexa is connected to Wi-Fi, and my light is also connected to my Wi-Fi. So yeah, if I want to operate this light, I can ask Alexa, like Alexa, could you please turn on this light? So it will just send the command to the PC, like Wi-Fi, and Wi-Fi will turn on this light. Okay, this is sending the command, and this is receiving the command. Okay, so if you want to create any IoT projects, you can use the ESP32 or ESP8266 modules. Okay, I can show you this relay module also. So if you want to control your lights or something, you can buy this simple relay modules. This is four relay. You can buy a single one also. That will take signal from your microcontroller and just give it to this pins. Okay, and this pin will just act like a switch for this thing. Okay, the relay module short the thing, short the wire, and you can just make a complete circuit. So that's how you can operate your lights and fans or whatever device you want and make it a part of your IoT device. Okay, I hope you understand. Did you understand
Yeah.
this part first of all? Your doubt is clear.
Yes, 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 it's clear.
Okay, anything else, guys? Any other doubt or something? Nothing. I'm completely new to this. First time I joined the session, but it was really interesting. Session. I understood God, but only you were explaining showing the code, but many things is completely alien to me. Okay, I will recommend just build the thing, okay, and then try to understand what's going on. In that way, you will understand more and more. Okay, if you are getting through some errors and all, you will try to explain. Okay, understand that. Okay, why this is getting an error, like this, then you will understand more rather than I'm just telling these things. Okay, that's also a point. Yeah. So if you guys, okay, like this course I'm ending now. If you guys have any issues, I will just help you guys in that chat. Apart from this, what course you want from my side? I can help you guys in IoT. I can help you guys in AI and IoT, something like that. What you want? Simple IoT you want? AI and IoT. Okay, so uh, Arunya is taking some sessions for AI. Okay, proper like how we can use LLMs and all to implement in real life. Okay, so maybe he will upload sessions like that, and I will take one or two sessions like this, the long sessions, and I will try to complete the thing in one go only. Because in like repetitive session, you are also getting bored, and I am also not able to explain anything. Okay, I hope that will work. And if you guys have any like doubt, I will just post this thing. The live, yeah, it's a live session link sent. Which live session?
By the way, is this session been recorded or
Yeah, it's being recorded. I will just upload in YouTube, okay, after some time.
okay? Is it under any playlist or in
It was
normal
part of
video?
bot building. It okay, I will show you this.
Yeah.
So there is a playlist called Bot Building 2.0. You can just see there, or mostly it will be there in YouTube. So you can just go and just see. I can show that as well. So this is our channel. My screen is visible.
No, it's just a black
Black.
screen.
This is black. Okay. Is it visible now? Hello.
Yeah, it's visible.
Okay, so I upload mostly like these sessions are part of board building only. Okay, and this is the last session we did. And if you want a playlist, this is the playlist we have. Okay, board building Nirman 2.2. And this is the first series we did. So if you got some error, you can just refer to one or two videos from here as well. The last two these sessions, session 4 and session 3, are for resolving errors only. So if you got any issues, you can just see these as well. Okay. Anyway, I've tried like in the max potential to just explain everything. In previous, it was like just building the thing. In this session, I tried to explain everything like